This section is about arithmetic sequences. The basic formula for an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 into d. A sub n is your final term that you're trying to find. Your a sub 1 is your initial term, which you're usually given, and your n is the number of terms you have in your sequence, and d is the difference. An example is, find the 47th term in the arithmetic sequence, -4, -1, 2, 5, and onwards. So the common difference between these numbers is 3, and your initial term is -4, and your n is 47, which is the 47th term you're trying to find for. So you plug it into the basic formula. A sub 47 is equal to -4 plus 47 minus 1 into 3, and your final answer is a sub 47 is equal to 134. This section is about arithmetic series. An arithmetic series is the indicated sum to represent the sum of a first of n terms of a series. The basic formula for that is S of n is equal to n over 2 into a sub 1 plus a sub n. S of n is your final term in your series, and n is the number of terms you have in that series. A sub 1 is your initial term, and a sub n is your back to your arithmetic sequences, so you use that formula to find a sub n. An example is, find the sum of the first 60 terms in an arithmetic series, 9 plus 14 plus 19, ... plus 304. So you plug everything into the sum of finite arithmetic series formula, and you get S of 60 is equal to 60 over 2 into 9 plus 304, and your final solution is S of 60 is equal to 9,390.
Okay, so we've done arithmetic sequences and series, and now we're going to do geometric sequences and series. So what the difference is with geometric is it's a list of numbers, but instead of them going up by a constant thing of, say, plus 2, plus 2, plus 2, it's going to increase by a common ratio that it's being multiplied. So it's going to be something like, so it's going to be something like 1/5, 1, 5, 25. So this is being multiplied times 5, times 5, and so on. So it's going to increase more and more instead of just being added. So my first thing I want to talk about is finding the common ratio of a sequence. So let's go back to the 1/5, 1, 5, 25. So how do I find what these numbers are being multiplied to get the next number? So in order to do that, I take any two terms and divide it by the one that was before it. So if I take 25 and divide it by the one before it, which is 5, I would get 5. And that's what each of these are being multiplied to get to the next number. And then, say if the question asks for the next 3 terms, all I do is multiply this number, I'll do it here, 25 times 5, and get 125, and then so on till the next 3 numbers. So now we're going to figure out how to find the nth term of a geometric sequence. So this is trying to find any term down the sequence, what is it going to be? And in order to do that, we're going to use the formula a sub n equals a sub 1 times r to the n minus 1 power. And what this is the term we're looking for, and a sub 1, this is the first term, r is the common ratio, what each term is being multiplied by, and then n, this is again the number term you're looking for, and you're just going to subtract 1. So let's try an example. Okay, so with the sequence 1/3, 3, 9, 27, and so on, So say we want to find the ninth term of this sequence. So we'd be looking for a sub 9. And this would equal, we start with a sub 1, which is 1/3, times the common ratio, which in this sequence, the common ratio is going to be 3. And I know that because, let's say we took 27 divided by the term in front of it, 9, we get 3. So it's going to be a sub 1 times the common ratio 3 to the n minus 1 power, and this is going to be, the n is the thing we're looking for, it's 9 minus 1. So let's solve this. 1/3 times 3 to the 8th equals 6,561. And 1/3 times 6,561 is going to equal 2,187, and that'll be your ninth term. So this is finding any term along the sequence and what it is. Now we're going to find the geometric mean, and this is used to find a missing number within a sequence. So let's say we're given the sequence 6, blank, and then 54. So if we want to find this number, we can't just multiply this by the common ratio because we don't know the common ratio. That's because we don't have any of the numbers before. So in order to do this, we're going to do something called solving for the geometric mean. And in order to do that, you take the first number, let's call it A, and the number after the one we're looking for and call it B. You're going to multiply these and take the square root of that. So in order to do this with 6 blank 54, we'll take the square root of 6 times 54, and this is going to equal 324, and the square root of 324 is 18, so that's going to go right here. And we can check our answer by solving for the common ratio and seeing that 18 follows it. So if we divide 54 by 18, we get 3, and 6 times 3 equals 18, then 18 times 3 will equal 54. So it all works out, and 18 is going to be the number we're looking for. Now we're going to find the sum of a geometric series, and in order to do that, we use the formula S sub n, which is the sum of n number of terms, equals a sub 1 first term times 1 minus the common ratio to the number of terms over 1 minus the common ratio. So here's our series, 4 minus 24 plus 144 minus 864. And first we're going to find the common ratio, and to do that, we take one of these numbers and divide it by the one before it. So here I have negative 24 divided by 4. That gives the common ratio of negative 6. So now let's plug it in to this equation. So let's find to the fifth term. So S sub 5 will equal 4, because that's your a sub 1, times 1 minus the common ratio of negative 6 to the fifth power, because that's how many terms we're looking for, over 1 minus common ratio of negative 6. And then that simplified will equal 4 times 1 minus negative 7,776 over 1 minus negative 6 is 1 plus 6. That gives you 4 times 1 minus negative 7,776 will equal 1 plus 7,776 over 7. And then that becomes 7,777 times 4 over 7. And all that will give you 4,444. And that will be the sum of this series, the first 5 terms of that series.
So in order to find the sum of an infinite series, if the ratio is greater than 1, then there is no sum of a geometric series, but if the ratio is less than 1, then there is an infinite sum of the geometric series. And so, for example, if you have the pattern of 24, negative 12, 6, negative 3, the ratio would equal negative 1/2. And so to find this sum, the equation is the sum equals a1 over 1 minus r. So you would take the first term, which was 24, over 1 minus the ratio, which would equal 1 plus a half, and that would equal 24 over 3 halves. That would simplify to 48 over 3, and so your sum of this is 16.
Start.
Now we'll go over sigma notation, and this is just a shortened way to represent a series and what its sum will be. So we use this symbol right here called a sigma, and below it we do n equals 1 for the starting term, and above it we do the last number of terms we'll have, and in front of it is a sub n, or the formula for the series. So from this series, let's figure out what the sigma notation will be. So let's figure out the formula for it first, and the formula for this geometric series, a sub n equals a sub 1 times r to n minus 1. And so we can do 3 for a sub 1. The common ratio r is going to equal -2, and then it's just the n minus 1. Below it, n equals 1, because it starts on the first term. And above it is a 5, because there's 5 terms in the series. And this will be your notation and sigma notation for that series.
The next formula is the compound continuous. The formula is A is equal to P e to the power of RT. A is the amount, P is the principal, R is the annual interest rate, and T is the time in years. For this one, you're going to have to use a calculator, as E has to be done on the calculator. An example would be you invest $1,200 at an interest rate of 5.5% compounded continuously. How much will you have in 5 years? So the formula is A is equal to P e to the power of RT. So you would plug it in, which is 1,200 e to the power. So on the calculator, it'll look like that, and then E is press second, and then go to ln, and then e to the power of 0.055 times 5, which will get you your answer, 1,579.83. The next section we're doing is compound interest. The compound interest formula is A is equal to P 1 plus R over N NT. A is the amount, R is the annual interest, which has to be in decimals, T is the time in years, and N is the number of times the interest is compounded per year. An example of this is you invest $1,200 at an interest rate of 55% compounded monthly. How much will you have after 5 years? So you plug it in, so it's A is equal to 1,200, 1 plus 0.055 over 12 to the power of 12 times 5, which is 1,578.53. Our next section is convergent and divergent series. Convergent are approaching a limit, and 1 is greater than r. Divergent has no limit, and r is greater than 1. R is the ratio. An example of this is -1/2 plus 1/4 minus 1/8 plus 1/16. Since it is geometric, r is equal to -1/2. 1 is greater than r, so it's convergent. For arithmetic, 10 plus 8.5 plus 7 plus 5.5 plus onwards, it's arithmetic. D is -1.5. Since there is no limit, it is divergent.
Limit notation for rational numbers is as the limit of x approaches a, fx will equal L, which is the limit. So if you have an equation such as the limit as x approaches 3 and x to the third plus 3x squared minus 7x plus 5, you would plug in the 3 that it's approaching and you would get your limit. So that's, doing the math, it would end up with 38 as the limit as x approaches 3. Limits that approach infinity are horizontal asymptotes, and to find it, you would take the largest number on top and divide it by the largest number on the bottom. So that would simplify to 8n squared over -2n, and that would be equal to -4n, and then you plug infinity in, which would end up equaling -infinity. For equations where the largest term is equal, the largest term on top is equal to the largest term on the bottom, you would simplify it, and for this one it would equal 1/2. Next is finding holes in limits. So if you have the equation of the limit approaching 0 and this equation, you could factor out an x and divide the x on top by the x on the bottom, so you would end up with the equation of x to the third plus 2x plus 3 with a whole at 0. Now you plug in that's the 0 that's left over and into the equation, and you'll end up with 3. So the limit as x approaches 0 is 3. With limits that approach from a positive or negative side, there's a different way to find the answer. So the first step is to plug in the number. So you would plug in 3, and since it wouldn't work, you'd end up with 0 on the bottom. Then you have to continue to simplify the equation. So plug a close number to 3 in, and since it's on the negative side, you want to pick a number that is less than 3 but extremely close. So I picked 2.99 and plugged it into the equation, and you would get 96. So x approaches 3 from the negative side, your limit will equal 96. So in order to find limits on a graph, you have to look and find where it is headed. So as x is approaching infinity, y value is approaching 0 and will never hit 0, so that is the limit. Now you do it with the same one, so as x is approaching negative infinity, y is going to be approaching 0 even though it may not touch it. So for finding the limit of x as it's approaching 2, since it is a horizontal asymptote, it does not touch and it does not exist as a limit. So on a graph of a straight line, finding the limit is easy because all you have to do is look at the graph. So as the limit is approaching infinity, as x is approaching infinity, y will also be approaching infinity because it is going in the direction. As x approaches 2, you just look at where 2 is on x and go up and find where y is. So the y would be at 2. Now, even though there is a hole here to find as x approaches negative 2, it will still be negative 2 as the limit, since it is approaching it even though it does not hit it. Due to the jump in the graph, the limit does not exist because of this discontinuity. So as x approaches 2, y would not be approaching anything because it would not be either of those numbers. So the limit does not exist. Now a limit doesn't exist if there is a horizontal asymptote, and as you can see there is one at x equals 2.